We're on page 94, topic 17, and the three problems we're going to do here are number 19 right here. We're going to do 22, both parts, and finally from number 23 we're going to do part D. So in number 19, the ratio of a father's age to his son's age is 3:1 now. 2 years ago, the ratio of their ages was 7:2. How old are they now? So what we're going to do is set up a ratio, what we call a now ratio, what's happening now. And you can see here's the father's age, and the son's age is y. X is to y is 3:1. 3:1 is 3. So this is the father's age. Obviously, the father's age has to go into the numerator, and the son's age has to go into the denominator in order to give you a number greater than 1. Now, if we cross multiply, this is 3/1, so we can say x equals 3y. So that's the age now. X equals the father's age now. Y equals the son's age now. Their ratio is 3. The ratio of a father's age to his son's age now is 3:1. Father's age, son's age, 3/1. Cross multiplying, this is 3/1. X times 1 gives us x, and 3 times y gives us 3. Now, 2 years ago, if this is the father's age now, 2 years ago, he would have been x minus 2. 2 years ago, if the son's age was y, his age would be minus 7/2, and that's what it says, 2 years ago. Now their ratio is no longer 3:1, but 7:2. So father's age 2 years ago, son's age 2 years ago, ratios to 7:2. Cross multiply, 2 times bracket x minus 2 equals 7 bracket y minus 2 here. So when we work this out and we do the distributive rule, we get 2x is 2x, 2 times minus 2 is minus 4, 7 times y is 7y, and 7 times minus 2 is minus 14. We bring the minus 4 over from the left to the right, and that becomes minus 10. 2x minus 7y equals minus 10. Now there's no way to solve this equation because there's two unknowns. Two unknowns. So how are we going to solve this? We don't have a method. If we have two unknowns, usually we must have two equations. Well, we do have another equation here. X equals 3y. So what we can do is just substitute for x and replace it with 3y. So instead of writing 2x, we write 2 times 3y. This minus 7y is this minus 7y, and this minus 10 is that. So all we're doing is taking this expression x here and replacing it with 3y. So we have 2 times 3y minus 7y equals minus 10. And if you work this out, 6y minus 7y is minus y is minus 10, so y equals 10, which is the son's age now. The father is 3 times as old. Let's go look up here. Father is 3y, so he's 3 times his son's age. 3 times 10 is 30. Now, to check the solution, we can see that as far as the age now, the ratio is 3:1, which is what you'd expect. Now let's go and see the son's age. If the son's age now is 10, 2 years ago he was 8. If the father's age now is 30, 2 years ago he was 28. So we take the ratio of the father's age to the son's age, 28 over 8. 4 goes into 28, 7. 4 goes into 8, 2. So the ratio is 7/2. For an official Canadian flag, the ratio of the length to the width is 2:1. Accordingly, find the dimensions of a flag with an area of 18 meters squared, a perimeter of 135 meters. So X is the length, Y is the width, and the ratio of the length to the width is 2:1. Length, width, 2:1. If we cross multiply, X equals 2Y. Now the area is equal to the length times the width, which is equal to 18, which we have here. So we have 18 equals XY. Now 18 equals XY, two unknowns here, but we know we could replace the X with the 2Y here. We can replace this X here with 2Y, and that's what we do here. So instead of X, we write 2Y. That way we only have one unknown. 2Y times Y is 2Y squared, and 18 is 18. And when we divide this side by 2, we get Y squared, and we divide this side by 2, we get 9. And Y is either 3 or minus 3. Now you can't have a negative length. So the width can only be a positive number, so plus 3 is the only solution. X is equal to 2Y, which is 2 times 3. Okay, we go back here, right here. X is 2Y, so X is 2Y, 2 times 3 from the 3 that we got here, which is 6. So 6 times 3 gives us the 18 meters squared right here. That's an acceptable solution. Now, in part B of the problem, we're asked for an official Canadian flag, the ratio of the length to width is 2:1. Same thing that we had in there, but the perimeter is now 13.5. Instead of given an area, we're given the perimeter. So first of all, we know that X to Y has to be 2:1. So X equals 2Y. The perimeter is twice the length plus twice the width. X is the length, Y is the width. So we have 2X plus 2Y equals 13.5. We are given the perimeter in the problem right here. So twice the length, twice the width is the perimeter. 2x plus 2y equals the 13.5. Now here again there are two unknowns, but if I replace x with 2y right here, I replace this x with 2y, I can get 13.5. Instead of 2 times 2y, I get 4y, and this 2y here is 2y. So all I'm doing is replacing this x with 2y. 2 times 2y is 4y, plus 2y is 6y. Divide, solve for y, divide this by 6, divide this by 6, I get 2.25. So the y is 2.25. X is 2y, which is 2 times 2.5, which is 4.5. So if I take, let's go back, x is the length and y is the width. X is the length and y is the width. Twice the length plus twice the width, 2 times 4.5. and 2 times 2.5. These are the two solutions that I got over here for x and y. 2.4.5 is 9. 2.25 is 4.5. We add the 2, we get 13.5. And if we go and check the problem up here, we know that the perimeter must be 13. 18.5. So in both these problems, we try to get a relationship between the x and the y. Of course, in one case we're given an area, one case we're given a perimeter. Now, find x in each pair of similar triangles. We're going to compare this triangle ABC, which is this one, to EDC. Notice this angle is 90 degrees and this is 90 degrees. This little square mark here is showing that this angle in here is 90 and this and this. So we're comparing this triangle here, that's triangle ABC, to triangle EDC, are similar. So we take a ratio of sides in both triangles. Let's take the ratio of CB to AB, CB to AB, because we know CB is X and we know AB is 20. This is X and this is 20. Now, in the other triangle, the triangle EDC, we're going to take the length of this side and compare it to the length of that side. So 24 is to 30. Let me repeat that. In the smaller triangle ABC, I took the ratio of this to this. In the larger triangle, I took the ratio of this to this, because these triangles are similar. So now I just put in what the values of CB are, and you can see CB, or BC, it doesn't really matter, is X, and AB is 20, CD, right here, is 24, and AD is 30. I cross multiply, 30x equals 20 times 24, which happens to be 480. So 30x equals 480 by cross multiplication. You solve for x. X is 16. So let's check the left side of this. X over 20 is 16 over 20, which reduces to 4 over 5. The right side of this is 24 over 30. 4 goes into 24. 6 goes into 24 4 times. 6 goes into 30 5 times. So they both reduce to 4/5. And that completes our discussion of page 94.